Okay, class, so the last thing I want to talk about in this slide, well, in this PowerPoint, is proving whether things are logically equivalent. When two statements are logically equivalent, we write double open arrows, okay? How do I prove if things are logically equivalent? I want their final column in their truth table to be the same. So let's go ahead and solve for an example. I'm going to change colors though. Okay, so let's consider not P and Q and not P or not Q. And I want to prove that these are logically equivalent. This is actually one of De Morgan's laws, which I'm pretty sure we talked about in chapter 5 about set theory. So let's go ahead and prove this. True, true, false, false, because there are 4 possible outcomes. Half of them have to be true, half of them have to be false. True, false, true, false. That way I get all possible combinations of true and false for P and Q. I look at not P, which is going to be false, false, true, true, and not Q, which is false, true, false, true. Okay, now I'm looking at P and Q. You can't even tell I wrote anything. Okay, P and Q. Remember, P and Q is only true if both P and Q are true. So I'm looking at these 2 columns here. So I've got true and true, which is a true, true and false, which is false, false and true, which is false, and false, which is also false. The next thing I want to look at is not P or Q. So I'm going to be looking solely at this column over here, and I'm just taking the negation of it, right? So it was true, now it's false. It was false, now it's true, true, true. Perfect. So I'm trying to prove that this is logically equivalent to this. So I need to solve for this given value here. Well, I'm going to look at the 2 columns, not P and not Q, and I have not P or not Q. Remember, or is true if one or the other is true or both of them are true. So I've got false and false, which gives me a false, false and true, which gives me a true, true and false, which gives me a true, and true, which gives me a true. So because the final columns, I should do this in highlighter, because the final columns of both of these are the same, they're both false, true, 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 these 2 statements are logically equivalent, and we can rewrite them. Not P and Q is logically equivalent, so double arrow open, logically equivalent to not P or not Q. Beautiful. Here they are. I highlighted in orange so you can see that they are logically equivalent. Let's check out one more example. So I have, are the following logically equivalent? Not P implies Q, and P exclusive or not Q. So let's go ahead and fill out this table. True, true, false, false, true, false, true, false. Now I have every possible combination of true and false for my statements P and Q. I take not P and not Q. Not P is going to be false, false, true, true. Not Q is false, true, false, true. Okay, now I want not P implies Q. Remember, this is only false if my hypothesis is true. This is the hypothesis. And my conclusion is false. This is the conclusion. Okay, so I have false implies, well, I want to look at these 2 columns right here, not P and Q. I have false implies true, which is true. I have false implies false, that's also true. True implies true, that's true. And true implies false, that's false. Okay, so that didn't quite work. All right, let's take a look at P exclusive or not Q. Remember, this is only true if I have that P and not Q, have the same value. So here I have to look at these two columns over here. I have one or the other is true, but not both. True and false gives me true. Oops. True and true gives me false. And as you can see, we already have a differing value, so this is not equivalent. False and true. Oh wait, I'm looking at the wrong thing. False and false, that gives me false, and true and false gives me true. So these are not logically equivalent.